Like F&M is already connected, we have some other primary sources, and we're particularly interested in how many other nonprofits in the community we can hook up and how to do it.
I'm Ken Goodwin with Three Rivers Optical Exchange, and we're always interested in trying to get more and more people connected and solving some of the last mile problems that we see with the more remote locations in our area.
I'm Dave Guerrero with the WLBT PBS station in Pennsylvania. I'm here to see if there's any opportunities for us to partner with Kimber.
My name is Carrie Cleary. I work with public libraries in Pennsylvania, working on a technology project now, thinking about connectivity, broadband every day.
Roy Hoover with Lancaster 11 and IU13 in Lancaster, Pennsylvania, and would love to connect to Kimber and just looking at any last mile options that we might have.
Mike Starner, I run a company called Access Fiber Solutions. We are a statewide CAP. We also build, engineer, maintain fiber networks for school districts and facilities like hospitals for private fiber. We also distribute video on demand, video conferencing systems for our customers.
I'm Alan Sutter from Franklin Marshall College. We are already connected to Kimber. We have lots of people in the area, PIU13, that ask us about getting connected to such a useful opportunity.
My story is the same as Alan. I'm also from Franklin Marshall.
Hi, my name is Tim Shortville. I'm new to Penn State, maybe 5 months, director of ops, so I'm trying to get a handle on all the different options.
Hi, I'm Christine Haas from Jersey Shore Hospital in Jersey Shore, PA, and I'm looking at options for the last mile connection to Kimber, and being a healthcare organization, I'm also interested in how hospitals can become part of Kimber and collaborate with other entities on Kimber.
Jim Davis, a consultant for Conxx with Cozen O'Connor Public Strategies.
I'm Jeff Mandel, the Chief Information Officer for Lackawanna County. We actually built the wireless network, and we'll be speaking about it tomorrow, which will be the second segment of what you're going to listen to today.
Hello, I'm Josh Schenkel. Here really in a dual role. I represent Adams County, working with the county commissioners to try and do what they did in Lackawanna County. Our success story isn't there yet, but I'll be on the panel tomorrow morning speaking as well. And I also work as a professional services CFO, as a service consultant for 2K Networking here in Harrisburg.
Hi, my name is Graham Garfield. I work for a community college in Allegheny County. I'm here to learn about last mile solutions.
Thank you very much. It really does help us to kind of understand who's in the group. You're our tech, right? Oh, why are you class?
I'm interested in one of the network engineers for Kimber. Another one in the back, one on the camera, but I'm one of the people that helps the packets move.
And so what we need to change that slide, I'm going right to you. And so with that, let me just introduce Dave, and please ask questions, grab us afterwards, grab us at the reception tonight, come to the session tomorrow. And this is Dave Karchner. So thank you so much for helping us get started.
Again, my name is Dave Karchner. I'm an Executive Vice President with Conxx. We're based out of Cumberland, Maryland, and have been operating there since 2004. Before that, we've actually been working with wireless communications for a lot of years. Our first network was built back in 1993 with illegal radios that were shipped from Israel through Canada in boxes marked dog food. So that goes back how far we actually started to work with some of this technology. And that network is what is now we refer to as AlphaNet 3. It's on its third revision and running full-blown MPLS backbone with a gigabit of capacity and last mile capabilities coming off of the tower system we have in the county to provide service all over a significant portion of Allegheny County, Maryland. We've been involved with this network really as we saw the potential of the network in Allegheny County. We knew that this was something that would be very beneficial to rural communities. And the thing that I'd like to really cover today, this is just kind of the timeline of what happened with the AlcaNet network. But today I would like to talk a little bit more about the wireless and fiber options that you have available to connect into the Kimber network. And it's all very much application and location dependent as to which option you choose, and a lot of times budget as well. But I would like to hopefully come away with so that you will have a better understanding of the technologies that are available, approximately how much they cost, and get you with enough information you can start thinking about what you can do as it relates to the Kimber network. Having that resource, that fiber resource to bring bandwidth into the community is just absolutely key to making any last mile solution work. And so the objective today now is to help you learn how to leverage that capability. There are two different types of connections that I'd like to talk about today. First will be the point-to-point, and then the other will be the multi-point. There are a lot of point-to-point options available. First, you have the ability to just build fiber from where it is to where you need it. The costs for that are fairly expensive, but it is a good option, especially if you need a lot of bandwidth. There are also IRUs. Now, IRU is a telecom term that is not typically used in the end user community. The end user, you might think of them more as leased lines from the carriers. So you have the option, and Kimber has the interconnections which allow you to order up leased line facilities from the local carriers, whether it be Frontier or Verizon or a lot of these other smaller regional carriers that are up in Pennsylvania. You have that option to order up a leased line which will get from your facility to their facility to provide bandwidth on your network. Again, it's one of the more expensive ways. It's a recurring monthly cost that's added in addition to the bandwidth that you're buying, but it is an option, and sometimes can be a good option depending on what you're trying to do. When you get into the wireless part of the network, there are a number of different options that you have available to you, and it's all spectrum dependent. We have licensed spectrum that's available, and we have registered spectrum that's available, and we have unlicensed spectrum that is available. The difference between the three, the licensed, when you go out and you secure one of those licenses, that spectrum is yours, and nobody else is supposed to be able to use that or put up other radios that would interfere with that particular license and that particular path. And every license is applied for with the FCC. It requires you to specify the height you're going to mount your antennas and the azimuths of the antennas, and and the bandwidth that you're going to be taking, the amount of frequency channels that you'll be taking in order to get the bandwidth that you're asking for that particular path. Licensed radios are more expensive than the unlicensed radios, but you'll have a much higher quality of service that can be guaranteed when employing that type of a point-to-point connection. You can also get higher bandwidth capacity when using licensed radios over the unlicensed type of radios. Your registered radios, there are certain frequencies that while you don't have to license a path, you do need to register with the FCC that you're using the path. So they have a record of it. But there are no guarantees that somebody else is not going to use that particular path or that particular frequency. So you still have the possibility of frequency interference when you use register. But at least you know who to talk to if you're having a problem, and then usually you can get together and work some things out. And those frequencies are going to be your 3.65 gigahertz radios, and then for public safety and utility use, you can use the 4.9 gigahertz frequency. And those are frequently used for public safety types of operations. In Pennsylvania, the 3.65 gigahertz is a little bit problematic in most areas because that particular frequency has some grandfathered users in the way of satellite base stations, and there's a lot of them, particularly in the east part of the state. There's also a few here in the western part of the state. So if you're at the Pittsburgh level and south in the western part of the state, you won't be able to use 3.65. If you're on the eastern part of the state, you won't be able to use 3.65 unless you get waivers from those base station license holders. And that's just something that takes quite a bit of time to process. Jeff, how long have we been working on that in Lackawanna now?
6 months in now.
Yeah, we're 6 months in, and I'm not sure if we've received a couple of responses back.
We're getting
But we're getting there, but it's a long process. You really want to plan on a year of time if you want to get access to those frequencies where you need grandfather.
Is that primarily like the Hawley base station and some of those?
Yes.
Yeah. In the northern part of the state, we run into that a little bit too.
Yes. Yeah, they're up there in the northern part, and then there's some down in the Maryland area.
Okay.
And so there's quite a few. I think there were I think 7 or 9 of them that we had to apply for Lackawanna County.
Okay.
Now the unlicensed spectrum is exactly that. It's free for anyone to use. And the challenges with it is that there's a lot more equipment that's starting to use it. Wi-Fi is now getting into the 5.8 gigahertz range a lot, so you're seeing a lot more Wi-Fi devices out there. And you know how many 2.4 gigahertz Wi-Fi radios are out. When you just look anywhere and you look at the list of SSIDs that are available for you to talk to, there's a lot of noise in that spectrum. And those are your primary spectrums for the point-to-point. The only other spectrum that's really coming out now that will be available is the new white space radio technology. And that is the old abandoned TV, unused old analog TV channels that are now being made available for use for broadband data. And those channels can also be used to establish point-to-point connectivity as well as point-to-multipoint connectivity. And the radios are just now becoming approved by the FCC, so there's not a lot of technology immediately available to make those connections. So those are your options again for the point-to-point. The other one that I did miss, well, the two, let's talk a little bit about the license and a little bit about the frequency spectrum as well, so you can have a little bit of an understanding. A rule of thumb, the higher the frequency, the more bandwidth the spectrum is going to be able to carry. And that is because you're going to get more waves in a given length. So if you take an inch or a foot of space, a higher frequency wavelength is going to give you a lot more ups and downs in which you can insert data than you would get with a low frequency, which is going to spread out those waveforms a lot more. So the higher the frequency, the higher the data capacity. However, the higher the frequency, the lower the penetration and the lower the propagating capabilities. If you need good propagation and good coverage, lower frequency is better. And you'll have to sacrifice one to get the other, and that's just the physics of microwave radio communication. However, with the compression techniques that are being used, you can get pretty good throughput with just about any of the frequencies now. But for the backbone and for your high capacity point-to-point connections, you want to use the higher frequency spectrum. The licensed and the registered millimeter wave technologies are interesting. Most of your public safety and homeland security connections are all done with licensed microwave. And the frequency that they use is based on two things. Number one, how far is your shot? You can do microwave shots as much as 25 or 30 miles. Typically, to get the larger bandwidth and higher reliability, you want to limit it to probably no more than 15 miles if you can. But you can shoot the licensed microwave shots a good long distance. And the longer the shot, the lower the frequency again that you would use. So for your really long shots, you want to be using the 6 gigahertz range. The other thing that determines which frequency you can use is availability. Because it is a licensed frequency, if you want to use a particular frequency and you go out and do a search on the FCC database, and that frequency you would create interference on that path for somebody else, you won't be able to license that frequency. So sometimes you have to pick a different frequency than what you would normally use just in order to be able to get some spectrum that isn't going to create interference for somebody else. So that's all part of the engineering process of being able to put in some of these point-to-point connections. Now the registered millimeter wave, 60 gigahertz and 80 gigahertz, are for really short shots. They're really designed, you can do some of the 80 gigahertz shots. I wouldn't really go more than 4 miles on them. The beam width on it is about the size of your finger, so you have to aim them very precisely. If they get out of kilter at all, you're going to have a pretty significant degradation of your signals, so you want to make sure that they're installed very well and very securely, because they won't handle movement well because of the narrowness of the beam width for those high frequency, ultra high frequency radios. And but you can get really good bandwidth out, 1 to 2 gigabits with the radios that are available today. And with the licensed radios, with some of the new technology that's available, you can also get up to 2 gigabits with the radios that are available for point-to-point connectivity today. Any questions on the point-to-point options? So the next component is the multi-point radios. Now what a multi-point radio does is it will put out a radio, it will have an antenna that will be able to transmit and receive radios within a certain pattern. And the antennas typically come in an omni form, which would give you 360-degree coverage, or in a sector form, which would give you the choice of a 120-degree or 90-degree radio. And in some frequencies, you can get 60-degree patterns, and then you would put up an array. When you've looked up and seen your cell towers, and you see how they've got those frames around and those really long antennas that go across and are facing out in different angles, those are sector antennas, and they're typically running at 120 degrees, and then they will stack them using different frequencies within that spectrum so that they avoid interference themselves, and they can really layer in a lot of connections on those radio arrays that they have up on the tower. And so for the last mile connectivity with multi-point radios, we would do the same thing. You have sector radios. You'll put up an array of those radios at your point where you want to distribute that last mile signal. And then you've got the ability out in the community, out in the field, to be able to aim a subscriber radio back towards that tower or that location where you have your array and establish a connection to the network. The multi-point radios, most of the licensed radios that are available are with spectrum that is owned by the cellular companies. There is not a lot of licensed radio. In fact, I don't know of any licensed radio spectrum that is available for end users outside of the cellular community, which has purchased the spectrum from the FCC at great cost to have a licensed last mile radio. So our options are the registered frequencies or the unlicensed frequencies. Those will work in 3.65 gigahertz. Again, you have that grandfathered issue. If you have any of those satellite-based stations, you have the 4.9 that's available as a multi-point radio, which can be used for public safety or utilities. And then you have the 5.8, 5.3 to 5.8, the 2.4 to 900 gigahertz in the white space that would be available in the unlicensed frequencies. The other last mile option is the Wi-Fi. And there are some very good Wi-Fi outdoor Wi-Fi radio systems that are out there. You've got Ruckus, you've got FireTide. Cisco has really improved their radio performance. So there's a number of them that are available that can make for very good Wi-Fi hotspots or coverage areas. And we'll talk a little bit more about that as we get into the presentation here. Are there any questions on the multi-point radio? Great. Now the installation costs, we've put ranges because it can really vary based on the equipment you choose and the nature of the location where you need to install it. And there are quite a number of factors that can go into it. For the fiber optic, installed dark fiber, that can run anywhere from $20,000 per mile to $120,000 or even more. I've seen more than that, but typically it will fall within that price range for getting dark fiber installed. You have the IRU, and you can get bandwidth. The nice thing about dark fiber is its capacity is only limited to the electronics that you choose to put on the end of it. So if you want to put on a 10 gig device, a router or switch, it would tie into that fiber or 192 gigabit switch. It doesn't matter. It's all related or limited only by the equipment that you put on the end. The fiber can carry really as much light as you can push through it. So it's the option that will give you unlimited growth. The IRU option is the carrier ordered leased lines. The 1.4 megabits is the T1 option, and you can get that anywhere from there. You can get more than the 10 gig, but you'll pay quite a bit for it. So, and that option is based very much on mileage, on the location of the POP, whether or not fiber is available from the carrier even, how much they're going to have to build, and they factor in all of those costs. So it's just one of those things that the price will be whatever they tell you it's going to be, and it's very difficult to put a range on it because there are so many variables. The licensed microwave, I really recommend not going much below 100 megabits on it. Most of the radios today start at 300 megabits for licensed radio of capacity, but you will only buy, they're license specific, so that you would buy from the manufacturer of the radio a license key which would give you whatever amount of bandwidth you're looking for. But the nice thing is, if you ever want to increase your bandwidth, you just buy an additional license key and make sure you have the FCC registration taken care of, and you can increase that bandwidth without having to go out really and touch the radios themselves. So your minimum capacity of a licensed microwave radio is typically 300 megabits. You would license probably starting at 100 megabits and then go from there as you need it. And you can go all the way up to a gigabit or 2 gigabits with some of the new radios that are out there now. And your cost with, notice I put the installed cost there, it's going to range anywhere from $20,000 to about $80,000. Sometimes more depending on the provider and the installer that you choose to work with. But that has been our experience in terms of the cost per link with all the installation, the licensing fees, the tower prep, and those kind of things that need to go on typically for a licensed microwave link. The millimeter wave license, that's the 60 gigahertz and 80 gigahertz, which are good for the 1 to 4 mile connections, typically less than 1 mile if you're using 60 gigahertz. Run typically anywhere from $15,000 to $25,000 installed. The point-to-point unlicensed 70 megabits up to 200 megabits are going to run anywhere from $200 to $9,000 per link. The variation in those costs is driven a lot by the quality of the equipment. You can get some equipment for very, very inexpensively, but qualitatively you'll see a big difference in terms of how well it's going to hold up. So if you've got a link that you need to make just for a short period of time, or it's just not that important to you, pay less and put in one of the cheaper links, and you'll be just fine with it. But if it's a more critical link, something you want to last and that you want to be more trouble-free, then it's worth spending the extra money to get one of the radios that's built a lot more solidly and is going to hold up to the weather and to the use over time. We've got radios in our network that have been running very, very solidly for over 10 years and don't show any signs of giving up, but they're quality radios. And you pay a little more for them, but in the long haul, it's really worth the extra cost. The point-to-multipoint base stations, and now these are the stations, the radio stations that allow you to create the arrays to get the 365-degree coverage. It's 360 degree, like 47 states or 57 states. 360-degree coverage for the arrays. Each radio base station with an antenna is going to cost you between $5,000 and $8,000 installed, typically. And that is all pretty much a very good, high-quality radio. You can get some that are less. I wouldn't recommend using those at all when you're getting into an array situation. You want to use a good, high-quality radio. If you want recommendations of some of the hardware to look at, we've used a lot of Radwin. We used to use Alvarion until they went out of business. They had a good quality radio. They struggled the last few years and ultimately didn't make it. And Ubiquity is making some good radios, a little less expensive. And we'll talk a little bit about that with this next bullet point, and that is the subscriber radio. With all of these multi-point radio systems, they're proprietary. And so whatever you put as your base station, you're going to need to use that manufacturer's radio as the endpoint out in the field. So when you make your selection on your base stations, you need to make sure you're going to be happy with that selection and with the cost of the subscriber unit. So you want to look at that whole package as you make any evaluation of what you would want to do last month. The subscriber units can give you anywhere from 1 meg to 200, actually that's wrong, it's not 200 meg. They typically give you 1 meg to about 40 or 50 megabits max of capacity. I would say closer to 40 than 50. Although the specs on something would say 50 megs, but I haven't ever. Are we getting 50 now? My direction is 100 actually. So we are getting some faster speeds with some of the newer radios. The cost per subscriber can run anywhere from $100 to $6,000 depending. Now the $6,000 on there, that's certain white space radios. White space technology is brand new. The first radios are just getting their FCC approval now. There are 2 radio manufacturers, 3 actually now, that I'm aware of, who have received on their first products the FCC approval to start marketing and selling those radios. Because they have just received approval, they haven't started actually they're starting the manufacturing process now, and the lead times are really long. So we are right at the very front end of white space radio technology. And on some of those radios, the subscriber units are very expensive. So white space technology, give it a little bit of time before you get too far down the road with it, because there needs to be a little more competition and market there needs to settle down a little bit because it is such new technology. Now the exciting thing about the white space technology is its propagation. We've run some tests with 2 different manufacturers of white space radios, and on both of these tests, we found that the propagation characteristics are absolutely wonderful for the area that we live in. You go outside and you see lots of trees, and this area here in the northeast part of the country is just burdened with all kinds of wonderful trees, which are wireless technology's worst enemy. And the white space technology really does a nice job of overcoming that problem. So it's something that has a lot of promise. We are deploying it right now in Lackawanna County. We are deploying it and have plans to do an extensive deployment along the waterways of the United States. We've already worked on a project along the waterways around Pittsburgh, and we have done some testing with white space along the waterways, and we're just absolutely thrilled with the kind of coverage we're going to be able to get with this technology. So it is one that will help us to get through the tree issue and get services to where we never have been able to before with wireless. And then finally the Wi-Fi for the really nice outdoor units. It's about anywhere from $2,000 to $5,000 depending on the quality and the range you're going to want to get with the Wi-Fi radio in the outdoors installed. Any questions about the cost model? I thought it would be helpful, so as you start to look at things, you can start looking at budgets and be able to formulate some initial plans. There you go. What I wanted to do is just show you a few different networks that, and all 3 of these that we're showing you are going to be tied into the Kimber network. This one here is located in Pittston, Pennsylvania, which is up near in the Lackawanna area. I think it's just over, is that still in Lackawanna, or is that now in? That is in Lackawanna County still? Pittston is a little city, and they want to cover their downtown area in Wi-Fi. And they have Kimber fiber that goes right through the city there. So we will be taking a connection from Kimber into their city office, which is if you kind of look, there's a sort of a triangle coming to the side there, that end point there where it's furthest to the right of the screen, right about the middle of those set of circles, is where the city hall is, and that's where the fiber, I think, is going to be coming into from Kimber. And from there, we were able to mesh those Wi-Fi radios and provide a blanket coverage of Wi-Fi all over the downtown area for Pittston, Pennsylvania. So that's one of the things we can do. Now, that you can also feed the Wi-Fi radios using a point-to-multipoint subscriber radio. So if you have a park, we're doing a lot of this in Lackawanna County. We have several parks that the commissioners wanted to be able to offer free broadband. So when you go to recreate in the park, you go there and lo and behold, you're going to have a good Wi-Fi connection in the park. And we're doing that by tying the subscriber radio to a Wi-Fi radio in the park, or to a set of Wi-Fi radios to get that whole park area covered, backhaul it over the wireless subscriber link to the multi-point radio, put it on the backbone where it will have its internet access. So there's a number of ways then of being able to implement and introduce Wi-Fi into your network. We have the entire city of Cumberland covered with Wi-Fi radios. We mesh groups of those radios together and then backhaul them, each of those mesh groups, back to the network using subscriber radios. The second design, and this is the one we've been doing for Huntington, and this is just an example. In the business park that they have that they would like to get lit up, they have access to the Kimber fiber. But the fiber is a long ways away from the other populated parts of the county, and there are other areas that they would like to get service. So what we're doing is a point-to-point, a gigabit link. That's the orange line that goes up to a tower on Jack's Mountain that is part of either the county's or the state's public safety tower system. We will have access to that tower, be able to put a point-to-point radio up. We can put a multi-point array, at least a sector of it. And right now the design is we have one sector that will come out and hit that area of Mount Union and the business park. Then we can also put an array at the business park to get really strong coverage down in the business park. And then from the tower on Jack's Mountain down the road, we can add another point-to-point radio and extend it out to another part of the county and provide service out there. So you have the ability then, once you start extending the network out, to be able to cover more and more area as funding becomes available.
Dave, can you just clarify what the colors mean in case?
Oh yeah, the colors on there, that is an actual propagation study. You'll notice there are some areas where you just see the regular Google Earth picture. That's where you've got valleys or low spots, or it's being blocked by a hill, so you get those dead areas in there. But all the red means you've got exceptional signal strength. The yellow and the green means you've got reasonably good signal strength. You'll be able to get connectivity in all of those areas. And where it starts turning blue, you're not going to have good connectivity. This is the Lackawanna County network, and it was designed to be a full coverage county network. It incorporates technology which allows it to be used for the public safety land mobile radio system. So that runs over the network. It also has broadband capabilities, so that it can provide both connections to government and schools, as well as commercial broadband to businesses and end user customers. So it's a full multi-service network. The backbone is made of 1 gigabit links, which are upgradable to 2 gigabit links. The technology, the switches that we have at each one of the tower locations there, it's designed kind of like a central office. So the switching equipment is the same switches that AT&T and Verizon and all the big carriers use in their POPs, where we use the Alcatel-Lucent 7700 and 7200 MPLS switches. And so it's a high-level MPLS backbone with prioritization, quality of service, all of the things that come with MPLS are all implemented here so that we can provide public safety with priority service for critical applications. We can prioritize voice over data and really provide the end users, all of the end users, with a quality experience for the services being offered on the network. Back to that one again.
That's the advanced operation.
Okay. Anyway, the other thing about the Lackawanna network is that if you were to study it closely, you'd see that there was one spur on the network design, but the rest of it was designed in a ring so that there was redundant paths to every endpoint, which would provide a very highly reliable network. So you lose a path, you don't lose the network. You don't lose a tower. You keep things going, and that's the way the whole network has been designed.
Do you interface that network with Kimber today?
Yes, we have the link isn't live, but we do have a link in place. We're still working through the agreement phase of it, but it's ready to go. Just a few of the decision factors that are going to impact your costs. Number one is going to be your selection of hardware. You can go cheap, you can go expensive, and again, it's all very much application dependent. Sometimes it's okay to go with something less expensive, but you really want to look carefully at what your applications really are, and install the appropriate equipment for what you're doing. Installation, depending on how much site preparation, whether or not you've got to pay lease fees to locate things on buildings or towers, those all can impact your cost model and need to be considered as you budget for one of these projects. Power availability is important, especially if you're doing any greenfield stuff. If you got to build a tower, make sure you build it where you get access to power, or else you're going to pay a fortune for getting power to that location. Site preparation, some sites are better prepared than others depending on what you're doing. Speed and reliability considerations. So again, that comes back a little bit to the quality of the equipment that you select. We talked already about the non-asset leases, the the frequency licensing and registration. And I might add, if you're using towers, there are tower studies that need to be done. When you're working with any towers, especially if they are public safety towers, they are required by law to meet a certain standard for strength. And when you put an antenna on that tower and you get snow and ice on it, which you get a lot up here in this area, That adds a lot of weight, and then when you get the wind blowing on it, and you figure how high some of those antennas are up on the tower, and you get you know, a nice surface and wind blowing against it, that puts a lot of leverage on that steel of that tower. So you want to make sure that the tower is strong enough to handle whatever you're putting on it. And so it usually requires an engineering study, and that would cost typically about $3,000. It'll be $5,000 if you don't have any documentation for the tower, because the engineer's got to come out and do it from scratch. But if you can provide them with existing engineering docs for the tower, it's less expensive. And it will cost you $2,000 to $3,000 to do it that way. You'll also need to consider where you're going to house the equipment. So you might need indoor cabinets, outdoor cabinets. The outdoor cabinets probably should have some environmental controls in them if you're going to do that. Or you might even put in a building shelter, depending on what you're doing for your installation. The ice bridges are very important. You want to make sure that you protect your cabling and your antennas that are on the tower from the ice that might fall off during the windstorm in the winter, or as if you've got a tower covered with ice and it starts to melt and they start to fall off. You know, once you get some ice that's falling 100 feet, it's going at a pretty good clip, and it can do tremendous damage to your installation if you haven't properly prepared your site for it. So those are all things that you need to consider. And then the total cost of ownership, of course, is taking into account any lease fees, any maintenance you're going to be paying on your equipment, and so forth. And with that, you can come up with a really pretty good estimate of what it's going to cost you to build and to maintain the system. Any questions about any of that?
I have a question going back a little bit about the white spaces equipment.
Yes.
There have been some white spaces trials going on last year.
Yes.
But I heard you say that white spaces equipment still needs to be approved by the FCC.
It's been approved for at least three vendors, and I know the fourth is they're in the process of getting approval. And it's in manufacturing now. It's still very hard to get the equipment. But the trials last year, we participated in some of those trials. We actually ran 2 different manufacturers' equipment, and we're very, very pleased with what we saw in terms of performance. You can get typically 5 to 10 meg of throughput. Are we seeing any more than that on any of these we're doing?
Not on the kind of reviews that you're saying about the ones that are coming out soon. But you know, that 5 to 10 megs doesn't sound very exciting, but you got to remember these are in places where elsewise you're getting no connectivity at all. So suddenly to go from nothing to having 5 megs, that's very nice.
Again, the limitation with white space is you're running at 400 to 600 megahertz. So the really low frequency. So it's that trade-off of penetration versus bandwidth. So you're not going to get as high throughput with the white space. You're going to get excellent penetration. And we're seeing the performance is good. The latency has been reasonably low, although the equipment we've got in place inherently has higher latency than we'd like to see that we've got installed right now. The equipment that we have on order, that we don't expect to see it until middle of June right now. That's about how far the lead time is, and we ordered it a month ago. We expect that latency number to go down and the throughput to go up.
Dave, I think it's fair to say that the technology has been used extensively on other continents, and it's really just being introduced in North America. And obviously the FCC licensing process is different than what some of the manufacturers would go through in other countries. But as Dave mentioned, I think that there's Redline, that's a Canadian company that has equipment that they say is ready to ship. Carlson has shipped equipment, and Adaptron is the one that is the newest stuff coming out. And I know that there is a fourth one that you're familiar with.
Adaptron is, they have a deployment right now at West Virginia University that has been very successful. And that's really their first generation radio they have there. They're coming out with a new second generation radio, which really reduces the latency down to where we really like to see it, and they've added a bunch of new features. So we're excited to get that radio. That's the one we have coming. The fourth one is Metric Systems, and it's going to be a higher end radio. It's more of a DoD mil-spec grade white space radio, but it's right now its pricing is it'll be the most expensive of the options from the pricing that I've seen so far. But typically, what we're looking at for white space radios, the base stations are going to be running right around, for the base station itself, somewhere between $3,000 and $4,000, or $3,000 to $5,000, I guess it would be. And the subscriber radios are running in the range of $1,200 to $1,500 a piece. So the subscribers are still kind of high. It's not the kind of service you're going to want to be going out and installing a lot of residential customers on. But what you can do, and this is the other thing that is an option, is you can use white space to backhaul into a neighborhood, and then you would put up another array of a different frequency just to cover that area where you're a lot closer. You don't have to worry about the distances, and you can get a neighborhood of 20 or 30 homes, or or a business park or something like that, and then backhaul that out using a white space. And you can use a white space point-to-point and get a little more bandwidth as well than just a multi-point if you choose to do it that way. So again, it's all very much what's the application, what do you need to get done, and then you can design for that and get the right thing in place.
At 400 to 600 megahertz, what do you see the bandwidth was about?
Well, it's going to depend, of course, on the signal strength of what you're getting. What I'm seeing up in Lackawanna with some radios we were actually working on earlier today, we were getting about 20 dB, which is a pretty nice signal, and we were getting 3 to 4 megs up, 3 to 4 megs down, so 6-7 megabits aggregate. And that is, again, that's a very real world number. That's not with the mesh. That's one of these links where elsewise we couldn't get any connectivity without building a 120-foot tower.
Yeah, and those links aren't clear at all. I mean, they're going through trees and got some terrain issues and everything else.
Yeah.
And we're getting that kind of throughput, so which is really good.
Lackawanna County built parks in a hole surrounded by trees. No matter how good the wireless technology is, you can't penetrate into that. The white space is actually working for the solution that we needed, which is basically provide Wi-Fi for public access Wi-Fi and 1 or 2 white phones, as well as a computer connection at the parks that were never possible before.
And Mr. Mando will let you know that on the phone I was jumping up and down. It's not going to work, guys. You're expecting too much of it. I'm not a sales guy. I'm the one who gets the phone calls and support it. And I'm thrilled with the performance of that, because at that spectrum you can just pound right through those trees. It's like they're not even there.
You can even pound through dirt with some of it. With some of the tests we did last year, I was astounded at. We actually, what we did is we mounted, we took the evaluation radios down to a point on the river, on the Ohio River, down towards the Ohio border, Pennsylvania-Ohio border, to a landing that's owned by Campbell Transportation. And we set up the radios there. It kind of sat on a bend of the river. There's a mountain behind us, and the river kind of came out on this bend, and it and it went down both sides. We oriented the antenna so that we could get a worst case scenario type of reading as the tow vessel that we put the antenna on as it went away and from the radio. So it actually moved very quickly out of the radio pattern, the primary radio pattern for the antenna that we had. We had a 120-degree sector radio on it. It moved out of that pattern rather quickly, and we ran that boat 2.5 miles up and down the river each way. You know how the rivers are along the Ohio here in Pennsylvania. I mean, you're basically in a